Here we have two rolls of coins, a roll of dimes and a roll of nickels. The roll of nickels is much heavier than the roll of dimes. What we're going to do is we're going to roll the roll of dimes into the roll of nickels and see what happens. Now, make a prediction. Do you think the heavier roll will continue rolling at the same velocity as the light roll hits it? Will it continue rolling with a slower velocity, or will it not roll and the lighter roll will hit it and bounce off and roll back the other way? Take a pick and let's see what happens. Hi there. So as we just saw, the light roll rolled into the heavier roll and they both continued rolling the same direction. The reason for this is while the light roll is rolling, it has a certain amount of something called momentum. Momentum is given by mass times velocity and measures how hard it is to stop an object from moving. The more massive an object, the harder it is to stop, and also the faster an object is going, the harder it is to stop. So, this object has mass and velocity and therefore is difficult to stop and has momentum. So, as it hits the other object, momentum must be conserved. So, you'll notice the velocity of the lighter roll decreases and the velocity of the heavier roll increases. This increase and decrease conserves momentum because a more massive object moving with a very small velocity and a less massive object moving with a slightly smaller velocity yields the same total momentum of the system, mass times velocity. Now, you may ask, why did they stop if momentum must be conserved? Well, I was unable to find a frictionless vacuum, so this floor does have friction. If you think about it in terms of energy, the kinetic energy of both objects is dispersed in the form of sound vibrations and heat given off into the floor, and the conversion of kinetic energy to